All right, here it is. Section 8.6, the end of chapter number 8. Quantum numbers. Now, quantum numbers, they give you the information about where an electron possibly is. It gives you all the subshell information, all the orbital information. There are a total of 4 different quantum numbers. Those quantum numbers, they're kind of the mathematical address for an electron. Those 4 quantum numbers are your principal quantum number, N, your angular momentum quantum number, L, your magnetic spin quantum number, M sub L, and your spin quantum number, or your magnetic quantum number, I'm sorry, M sub L, and your spin quantum number, M sub S. Your principal quantum number, N, you can get that straight from the periodic table. This identifies the principal energy level, the first energy level, or shell of an electron. These values are going to be positive values, and they start with 1. They can be 1, 2, 3, 4, 5. So N cannot be 0. N cannot be -1. Your angular momentum quantum number. Well, your angular momentum quantum number, L, is going to be defined based on an N value. This is going to have a range from 0 all the way to 3. So if you are told N equals 3, then L can equal 0, 1, and 2. If N equals 3, L cannot equal, well, oops, excuse me, it cannot equal 3. L cannot equal -1. It ranges from 0, 2, and -1. The last 2 quantum numbers, your M sub L and M sub S. Well, M sub S, I'll start with that one. It can only be -1/2 or +1/2. That's the specific electron within an orbital. If you remember when we were doing energy diagrams, it was either up or down. It's kind of the same thing, -1/2 or +1/2. They are opposite, and they are equal in magnitude. M sub L. Well, you're going to derive your M sub L value from your L value. So that's going to range from -L all the way to +L. Okay, now one way that you can look at that is your angular momentum is the type of subshell, or type of sublevel. So if L equals 1, that is the same as you have a orbital that is shaped like this. Now that orbital, that's our p orbital. If you remember that p orbital, we could have it in this position, it could be in this position, or it could be in this position. How many different positions is that? That's 3 different positions. If your L equals 1, that's going to be the same as -1 here, 0, and +1. Okay, so this is, it's kind of abstract, but I think that if you understand these rules, you're going to be in good shape for this. If you've understood everything up until now for this chapter, you're in fantastic shape. This all takes practice. Defining these different quantum numbers and understanding that these quantum numbers are all about ranges and what they can be valued at, that's going to help you out a whole lot through this. All right, y'all. That's the end of chapter 8. Got chapter 9, 10, and 11 left. You got this.